Ok, estudantes, você está vendo aí que é mais um bloco de estudos. Eu estou utilizando esse modelo aqui para me manter motivado para estudar. Eu estou estudando 1 hora de psicologia durante 4 dias, ou seja, 4 horas por semana. Nesse momento, eu estou ativando aqui o meu aplicativo de transmissão, meu aplicativo de bloco de tempo. O nome dele é Productivity Challenge, ok? E olha só, dá uma olhada nele. Esse é o aplicativo. Então eu coloquei aqui o projeto estudante. Deixa eu pegar aqui. Vocês estão vendo a minha tela, né? E eu vou começar a estudar aqui. O que eu estou estudando exatamente? Eu estou pegando aqui o... Iniciei. O que eu estou fazendo basicamente é estudando esse curso aqui da Coursera, que é o Introduction to Psychology, do Bloom. E vamos começar aqui.
Brain for everything. There's certain activities we do that can happen without a brain, like sucking in newborns or pulling your limb back to withdraw from pain or vomiting. But for everything else we talk about in this course, we really will be talking. So let's talk about the different parts of the brain and what they do. Parts of the brain are functionalized for different purposes. They do different things, which is why damage to different parts of the brain has different effects. It's why when you look at an fMRI scan or a PET scan or some sort of something that records neural activity, you could figure out based on the location of the activity what's going on. So the first thing to realize is I'm talking about the brain, but I'd be more precise and more inclusive if I talked about the brain and parts of the spinal cord. So you don't need your brain for everything. There's certain activities we do that can happen without a brain, like sucking in newborns or pulling your limb back to withdraw from pain or vomiting. But for everything else we talk about in this course, we really will be talking about the brain. So some of the structures of the brain that are highly relevant are called subcortical, which means they're below the cortex, which means they're sort of in the center of the brain. And this includes part of the brain like the medulla, which controls certain automatic function like your heart rate, your blood pressure, swallowing, and so on. It includes the cerebellum, which is involved in body balance and muscle coordination. It contains about 30 billion neurons. So this isn't small potatoes. The hypothalamus, which is involved in feeding and sex and thirst and different appetites. A lot of the sort of when we talk about emotions or visceral desires, we'll return to those parts of the brain. But for the aspects of psychology that are distinctive for us, that make us human, we're mostly focused on the outer layer, the cerebral cortex. So the cerebral cortex, it is all crumpled up. If you were to take a brain, pull out the cortex, and straighten it out, you know, like you're removing a rug you got from the trunk of your car and you have to straighten it out, it's about 2 feet square. So it's a lot of crumpling to get it in. It's about 3 millimeters thick. And this is where the action is. This is where, at least for the sort of things I'm interested in, this is where it takes place. It's where reasoning and language and complex perception comes from. Fish don't have any cerebral cortex, reptiles and birds have a little bit, but primates, including humans, have a lot. And when you look at the cortex, you'll see it has 2 halves. It has a left half and a right half. And for each of these halves, when you look at it, you can demarcate the brain, the cortex, into different lobes. There's going from sort of your forehead and swooping to the back. You have the frontal lobe, conveniently enough in the front, the parietal lobe, the occipital lobe, and the temporal lobe. And each of these lobes does different things, which we'll talk about in a bit. Another thing about the cortex, though, which is super interesting, is that it includes maps. And what I mean by this is it includes topographical maps, where 2 things that are close together in the brain are similarly close together in the body. So there's a motor area where if you were to shock parts of that brain, parts of the body would twitch accordingly. And just like you'd expect, you know, the middle finger is, you know, is close to the thumb, which is close to the elbow. If it's close in the real world on your body, it's close to the brain. And there's primary somatosensory area, which is sense organs. And there, if you have somebody on an operating table and you shocked people, they would experience things. They might experience a sound or a flash of light or a touch. And in fact, in the occipital lobe, you have a map for vision, and in the temporal lobe, you have a map for sound. What's really cool is, I said the map is topographical, but the size of the brain areas don't correspond to the size of the actual body areas, but rather to the extent to which there's motor or sensory function. So artists have drawn pictures of people if their body was proportioned to the extent that their brain was. And you'd see they had the trunk of the body is relatively small, but the hands are enormous, and the face is enormous, because there's a whole lot of sensation. There's much more sensation going on in your hand than in your whole back, even though the back is physically larger. So part of the cortex is these projection areas, but less than a quarter of the cortex contains projection areas. As I said, the rest is involved with the cool stuff, with language, with reasoning, with moral thoughts, and so on. And then the question comes in, how do we know this? How do we know what parts of the brain do what parts of the brain are involved in what? And there's different answers. So one answer is we can scan the brain. We could use MRI, which is a high-frequency magnetic field, to look at the activity of the brain, what parts are active when people do different things. We can also look at, so-called natural experiments, when people have tumors or strokes or motorcycle accidents and damage part of their brain, and we can ask the question, what damage to which parts of the brain correspond to damage to which functions? Through these different methods, we've learned about the different parts of the brain and what they do, and we could talk about some certain specific things that can go wrong due to brain damage or stroke or trauma. So for instance, there's apraxia, and apraxia is problems with actions. So you're unable to do an action like waving goodbye or picking up a fork and bringing some food to your mouth. You're not paralyzed. You can make the movements if you have to, but you can't coordinate these basic movements into complex actions. There's agnosia. Agnosias are disorders of perception. And they're not like you can't see, but you can't recognize. Something's called psychic blindness. People with various forms of agnosia can describe a picture in terms of its part, but can't recognize the objects that are being depicted. And that's sort of a form of visual agnosia. There's also a specific prosopagnosia, where you can't recognize faces. Oliver Sacks wrote a wonderful book many years ago called The Man Who Mistook His Wife for a Hat. And this was a series of profiles of people who had surprising neurological disorders. And the case, that the title case of the book, was a man who actually had such an inability to recognize faces, he couldn't distinguish his wife's face from that of a hat. Milder forms of prosopagnosia, which some people suffer from, and to be honest, I got a little bit of this, I'm terrible with faces, is that you could recognize faces as faces, but you can't recognize whose face they are, and it's very hard for you to recognize people. There's problems of sensory neglect. You get disorders that kind of block out one part of the world. You might have damage to parts of your brain that would block out the left side of the world. And it's not just a sort of physical thing. When you ask somebody with such a disorder to draw a clock, for instance, they'll put all the numbers from 1 to 12 on the right side of the clock. It's as if they don't think of the left side of the world again. So maybe it's not even a sensory problem, but an attentional problem. There is aphasia, which refers to disorders of language. Some forms of aphasia are expressive, like a Broca's aphasia, where you can't really speak. A famous case of somebody who could only use the word tan, would say tan, 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 but couldn't say anything else. Or then there's sometimes called receptive aphasia, where you can speak, although what you say doesn't make much sense, but also you have a terrible time understanding other people. Then there's all sorts of other disorders. There's a disorder which we talked about with regard to Phineas Gage and various forms of it, where damage to parts of your brain, and it's debatable whether this is true of Phineas Gage, but there are other cases where it's much more clear. It causes you to lose your moral sense, your sense of right and wrong, your ability to control yourself, to restrain yourself, perhaps your conscience. Now, we're going to talk about all of these things through the course, but the moral here is that A, there's some localization of function, there's some sense in which these correspond to different brain areas, and B, again, this is an argument against dualism. We could see that in that anyone who argued that the mind isn't the brain would be hard-pressed to explain why damage to the brain seems to affect some very intimate and very important aspects of ourselves.
entre o materialismo e o dualismo. Materialism and dualism. Ok, então nessa aula ele falou sobre partes do cérebro. E ele falou várias coisas ali que eu simplesmente não acho muito interessante memorizar, mas que tem várias coisas para memorizar. Então ele falou sobre basicamente duas partes do cérebro, que são as subcorticais, as estruturas subcorticais, e o córtex. O subcorticais está abaixo do córtex e o córtex está aqui. Aí ele fala que no córtex ele é dividido de lobos, e aí você tem vários sublobos dependendo da área que você está olhando. Aí ele deu o nome dos lobos, que se você quiser decorar, dá para decorar, mas eu não me importo tanto assim em decorar isso não, porque tem muita informação para mim aprender. É igual o lance, você decora palavras ou não decora palavras. Resposta minha, do Adriano: não decore palavras, simplesmente use elas no seu cotidiano. Uma hora ou outra você vai acabar memorizando elas, porque elas fazem parte do seu dia a dia. Vamos passar para a próxima aula. Our two brains. Ele está falando sobre o left side and the right side.
We've talked now about the parts of the brain, a little bit about what the different parts do. And let's end by talking about the brain as a whole. So if you just look at the brain, if you remove it from somebody's head and put it on your table, it looks symmetrical. But it's actually not. And so this final topic is about what's called lateralization, which is about the difference between the two halves of the brain, the right half and the left half. It's long been known that there's a difference between right and left. We're not symmetrical creatures. Most people are right-handed, meaning that they do a lot of their motor control and they're most fluid and capable, like handwriting with their right hand. And a minority of people are left-handed. And then some people are evenly mixed, ambidextrous, right and left. People who are right-handed, for the most part, have language in the left half of their brain. And people who are left-handed are more evenly mixed. Some people have in the right side of the brain, others in the left side of the brain. So the cool thing is that most functions of your brain are duplicated. So a lot of times when you hear somebody say, oh, the right side of the brain, the left side of the brain, and right brain and left brain, a lot of what people say about that is total nonsense. Most of the functions of the brain are on both sides, and to a large extent it's sort of more of an issue of dominance or greater potential in one side than another than an absolute difference. But as the sort of common wisdom goes, the left brain is more associated with written language and spoken language, with reasoning and logic and science. And the right brain is more associated with insight and imagination and music. So we have these two halves of the brain. And normally they're in coordination. But they deal with the world in different ways. So one thing worth noting in any discussion of the halves of the brain is that it works on a principle of contralateral organization, which is an awful technical term, but what it means is that your right brain sees the left side of the world, the left visual field, and the left brain sees the right side of the world. It just works out that the brain has this crossover effect where each half of the brain is looking towards the opposite half of the world. And similarly for motor control, your right hemisphere controls the left side of the body, your left hemisphere controls the right side of the body. Now, you might say, well, this is ridiculous because I'm one person. I'm not two people. I can understand language and appreciate art. I see the world as a coherent scene. I don't see the world with half of me and see the other half of the world with the other half of me. But that's because the two halves of the brain are in constant, immediate conversation. It's through the corpus callosum. And the corpus callosum is a network of neurons that connect one half of the brain with the other half. And this is what allows sensory information that's received on the left side of the brain, for instance, to be appreciated from the right side of the brain. It's what allows the left side of the brain to control the motor actions on the right side of the body, because it could send instructions over to the right side of the brain to do it. In fact, you can see in some clever experiments the strange organization of the brain. So for instance, if you flash on a screen very quickly something on the right side of the body, you're quicker to name it than if it's flashed on the left side of the body. Well, why would that be? Well, think about it. If it's flashed on the right side of the body, it's immediately perceived by the left hemisphere. The left hemisphere is where spoken language is. So you say, oh, it's a cup, it's an apple. If it's flashed on the left side of the body, for a fraction of an instant's delay, it has to cross over to the left side of the brain. And you'll never see this in everyday life. The time differences are just too small. But in the psychology lab, you can see this. Now, what becomes really interesting is that for almost everybody, the two halves of the brain are in constant conversation. But not everybody. So, a while ago, people with severe epilepsy, they would cut the corpus callosum. Epilepsy could be viewed as an electrical storm in the brain. The corpus callosum causes the brain to communicate from one half to another. So cutting the corpus callosum in some way, the idea would be it would isolate and shrink the electrical storms. And so people did work on that, where they did this very severe form of surgery on people with terrible cases of epilepsy. And the consequence, which they didn't anticipate, is all of a sudden you break one person off into two, to some extent. You have a left side of the brain, which does the talking, and a right side of the brain, which does a lot of other things, which appreciates music and space and so on. And the idea is that in some sense you've taken a person and now you have two, one half of them who can speak and articulate their wishes, the other that can't. And making sense of this, what this means, what this does to a person, leads to philosophical questions that fall outside the scope of this course.
Nossa. Bom, acabou a aula aqui. E uma coisa que ele passou que é bem interessante nessa aula...
We've talked a little bit about materialism. Why?
Pausa aqui. Ele falou sobre os nossos dois cérebros, o lado esquerdo e o lado direito. E ele falou sobre laterização, que é tipo, a gente não é simetricamente o lado esquerdo e o lado direito, mas a laterização meio que que deixa a gente entender o que o lado esquerdo está fazendo, o que o lado direito está fazendo. No vídeo passado, nos partes do cérebro, ele falou de algumas coisas interessantes que o cérebro faz. E como é que a gente descobre essas coisas interessantes. E ele citou dois exemplos, que a gente escaneia o cérebro e a gente percebe o que causa na pessoa depois de um dano. Então, se a pessoa sofreu um acidente no cérebro, o que acontece com a pessoa depois? Aquele lado do cérebro era responsável por tal ação, e agora que ele foi lesionado, o que está acontecendo com a pessoa? E aí, por causa disso, a gente descobre vários assuntos, que nem aquele caso do... Qual que é o nome dele? É o Phineas Gage, que foi perfurado na cabeça. E aí, na lateralização, ele fala dos crossovers, que são os cruzamentos entre os dois hemisférios. Ele fala que o olho esquerdo é responsável pelo que eu vejo exatamente, e a mão direita é controlada pelo lado esquerdo do cérebro, e um lado é responsável pela fala, o outro é responsável pelos sentimentos. É bem interessante. E ele falou como é que esses dois cérebros se comunicam, basicamente pelo corpus callosum, que é uma integração de nervos entre o lado direito do cérebro e o lado esquerdo do cérebro, que se comunica. E ele falou no finalzinho, bem interessante, que são pessoas que têm epilepsia, que são necessários remover cirurgicamente, ou cortar o corpus callosum cirurgicamente. E uma coisa extremamente interessante e estranha acontece, que é o surgimento de duas pessoas dentro de um só corpo. E o interessante é ele saber de perguntas filosóficas, se existe só você aí dentro, porque a partir do momento que eu corto a comunicação entre o lado esquerdo e o lado direito, você começa a perceber no indivíduo que teve esses lados cortados uma ação diferente, ou seja, um lado do cérebro quer uma coisa, o outro lado quer outra. Mas aí, como um lado é responsável pela fala, o outro não consegue falar. E como um lado é responsável pelo que vê, o outro não consegue ver, não consegue entender o significado, por exemplo, de alguma imagem, não consegue fazer essa representação, e ele precisa do outro lado. E aí você consegue, pelo que ele falou, em laboratório, enxergar isso. Se eu não me engano, em um dos episódios do Dr. House, ele tem um paciente que tem um braço que faz isso, ele meio que age por si mesmo, e o dono desse braço acha super estranho porque que o braço dele fica agindo sem ele controlar exatamente. Ok, deixa eu passar aqui para a última aula, que eu tenho mais 10 minutos de aula de psicologia até eu acabar esse bloco aqui.
Psychologists believe in it, some evidence for it. And then we've taken a quick tour of the brain. But the broader gist of things is what I want to return to. And this is that the current view by psychologists and neuroscientists and other scientists, bolstered by a lot of evidence, is that dualism is wrong. The mind is the brain. There's not two substances, there's one. And I want to remind you how radical this is, because I want people to worry about it. I worry about it, and I want people to worry along with me. So, for instance, you might believe in spiritual beings and supernatural beings with consciousness but no bodies, like gods. If materialism is right, not only don't we have souls, but maybe there's no such thing as souls. Or to put it differently, there's no such thing as mental life separate from the body. More to the point, maybe you were hoping that when your body dies, when you get very old or you get hit by a bus or whatever, you'll live on. You go to heaven. You go to a spirit world or get reincarnated or whatever. And psychologists and neuroscientists, if they speak honestly, would say, that's crazy. You, your memories, your will, whatever makes you you, is your physical brain. And when your physical brain goes away, so do you. So people have to figure out what to make of it. What I want to close with, though, since this all sounds not only disturbing but extremely arrogant, the idea that scientists are sort of dictating the answers to the most deep questions of all, is I want to end with two notes of humility. The first is the conception of the mind that fits very well with the materialist view I presented, is that the mind is an information processor, it's a computer. And we treat the brain as the physical aspect of hardware, and our mental lives, the ideas, our processes, our heuristics, our algorithms, as the software, as the programs that this hardware runs. And this way of looking at things, I think, works extremely well when it comes to activities like face recognition, language, motor control, logic, and so on. But there still remains what the philosopher David Chalmers has called the hard problem of consciousness. The feeling of what it is to slam your hand in a car door, or, eat scrambled eggs with hot sauce, or have an orgasm, or grieve for the death of your friend, or etc., etc., etc. These feelings, the feeling of what it's like, the qualia, that many people believe can't be simulated on a computer. And many people wonder whether this could be truly the activity of the brain. If it's true, as I think it is true, that that even these most qualitative experiences are the product of brain activities, I think we should admit that we don't exactly know how this happens. Yes, there's a quote by Thomas Huxley. How is it that anything so remarkable as a state of consciousness comes about as a result of irritating nervous tissue? That question is just as unaccountable as the appearance of a genie when Aladdin rubbed his lamp. Huxley's saying it seems like magic. How a physical structure irritated by neurotransmitters swooshing back and forth and electrical signals running across neurons, how that gives rise to feelings is a mystery. It seems like magic. And I think he's right.
Yes.
I think we know that it's the product of the brain, but to be honest, we don't know how. The second bit of humility involves the fact that materialism poses a mechanistic conception of mental life. But a lot of us, both as scholars but also as people, are concerned with what you can call humanist values. Values like the notion of moral responsibility, the idea we have free will, the idea that we're responsible for our actions, the idea that there's such a thing in the world as intrinsic value, the idea that there's such a thing in the world perhaps as spiritual value. And for some people, it's very hard to reconcile this with the idea that we're merely brains. And there's two ways to react. One can simply reject humanist values And I know philosophers and psychologists who confidently assert there's no such thing as free will. There's no such thing as morality. There's no such thing as anything sort of higher or spiritual. I know many more people who reject the science, who says, will say, look, if neuroscience is going to tell me that my decisions, my activities are nothing more than neural firings, then to hell with neuroscience. My own view is that these two things can be reconciled. I don't think it's easy, but I think that it's possible to reconcile a mechanistic conception of human life with humanist values. And I'll return to this issue over and over again in the course. And in my final lecture, I want to go back to it and try to present a little bit more detail what I mean and how this reconciliation can be defended.
Uma reconciliação. Tá, então ele falou sobre a humildade que você tem que ter quando você estiver analisando essas questões de psicologia, falando sobre o cérebro e tudo mais. A ideia dele é que hoje já é reconhecido que o dualismo está errado, ou seja, a ideia de que você tem uma mente outside your body, ou seja, fora do seu corpo, ou seja, uma coisa que controla o seu corpo, está errada, né, pelo que ele está me falando. Mas aí olha o título da aula, A Bit of Humility, um pouco de humildade. Por quê? Porque a ideia do dualismo está errado é que a mente é igual o cérebro. Por isso que quando você sofre algum dano no cérebro, há uma mudança, até mesmo uma transformação em quem você é, porque aconteceu alguma mudança na estrutura biológica do seu cérebro. E aí, ele falou uma coisa interessante que isso acontece, a gente vê isso acontecendo, mas a gente não sabe como. E aí a dúvida que gera como é que uma coisa, um pedaço de carne, de, sei lá, 2 quilos de carne, através da excitação de neurônios, né, transformação lá dos negócios, consegue emular a consciência. Eu acho que essa foi a questão final que ele passou. Como é que ele consegue emular a consciência? E a gente não sabe como, porque se for como um computador ou como um animal qualquer, ele tem lá um set of protocols, né, um conjunto de ideias de if this, so then, ou seja, se acontecesse X, faça Y, e aí na natureza ele simplesmente age conforme os protocolos vão mandando. O ser humano é um pouquinho diferente, é claro que se a gente intervir na condição dos animais, da natureza, esse if then também pode ser alterado. E conforme a evolução vai acontecendo, esses if then da natureza também estão sendo alterados. E aí é uma discussão bem interessante e meio que foge do escopo da psicologia, talvez, e vai direto lá, ou para a filosofia, se você quiser ir mais profundamente, ou ainda pro lance da neurociência, tentando encontrar dentro da carne, dentro do cérebro, o que é essa consciência, se ela realmente existe, ou se a gente é só mais um animal super complexo, que é complexo porque a gente não sabe o que está acontecendo. Aqui, para finalizar aqui, essa live, talvez eu finalize, tem aqui a recomendação do livro The Brain, né? Back, de 2018, The Brain, blá blá blá, nova textbook series, Psychology Campaign, e tá aqui, eu vou abrir esse livro aqui para ler um pouquinho sobre isso daqui, uma explicação sobre o que é o cérebro, ok? Então, eu tô vendo o bate-papo aqui no celular. Então olha só que incrível, isso aqui é um livro sobre psicologia completo, é um livro completo, gratuito, sobre não é biologia exatamente, mas psicologia. Ok, the human brain is responsible for all behaviors, thoughts and experience described in this textbook. This module provides an introductory overview of the brain, including some basic neuroanatomy and brief description of the neuroscience method used to study it. Ok, Vamos lá, Learning Objectives. Aqui no lance da neuroanatomia, dá até para decorar alguma coisa e fazer alguns flashcards do Anki. Mas aí eu vou anotar no mapa mental e depois, na minha 1 hora de adicionar ou revisar no Anki, eu faço esses flashcards. Learn Objectives. Quais são os objetivos aqui? Vamos lá. Name and describe the basic function of the brain stem. Esse stem é uma palavra que eu não conheço. Stem. Cerebellum and cerebral hemispheres. Name and describe the basic function of the 4 cerebral lobes: occipital, temporal, parietal and frontal cortex. Isso daqui dá até um checklist, né, para mim revisar depois, para mim ver se eu fazer uma escrita ativa dessas informações. Describe a split brain patient and at least 2 important aspects of brain function that these patients review. Distinguish between gray and white matter of the cerebral hemisphere. Name and describe the most common approaches to studying the human brain. Distinguish among 4 neuroimaging methods: PET, fMRI, EEG, and DOI. Describe the difference between spatial and temporal resolution with regard to brain function. Eu gosto dessa palavra, regard. Introduction. Ok, então, para ler um textbook é um pouco diferente, mas quem criou esse textbook já tinha essa ideia na mente. Primeira coisa que você faz antes de ler um textbook é saber os objetivos, os seus objetivos. Ok? A introdução nem é importante você ler agora, mas é legal você fazer um skimming do texto. Um skimming só prepara o seu cérebro para consumir o conteúdo. Como eu vou estudar, tenho 30 segundos aqui para acabar isso daqui, eu vou deixar isso daqui para amanhã. Ou seja, acaba o meu tempo, mas basicamente eu vou fazer uma leitura, um skimming do texto, dar uma lida, depois eu tentar tirar da cabeça o que eu peguei ali, alguma coisa que eu tenha pego. Depois eu vou rabiscar um rascunho disso daqui. E aí eu vou criar uma estrutura desse texto com os objetivos em mente. Ok? Outside resource. E aí acabou. Ó, tem vídeo, ó, fantástico. Fantástico. Tem, oh my god. Olha só isso aqui. Tem o vocabulary. Tem o vocabulário. Entendeu? Isso aqui eu posso correr atrás antes de ler o texto. Então, para dominar esse texto aqui, cara, dominar mesmo, eu vou precisar de 1 semana, no básico. Então, aqui eu já posso dar uma pausa nesse negócio aqui, porque eu vou demorar 1 semana para dominar aquele texto ali. Eu vou realmente dominar ele. Então, eu já salvo aqui dentro de uma pasta, que é o estudante. Ó, é a minha pasta. Eu vou fechar aqui. Porque amanhã, a minha 1 hora de psicologia vai ser reservada para esse livro aqui, esse textbook sobre the brain. Ok? Então, ó, o bloco acabou e talvez a live para o bloco de programação, mas até o próximo. Eu vou finalizar aqui com o meu OBS que eu estou aprendendo a usar. F10, se eu não me engano, encerra.